So starting off in this video, we're going to be talking about the Raoult's law and problems where you apply that Raoult's law to. If you remember, Raoult's law is where the pressure of whatever you're looking for, the solute or solvent, is equal to the mole fraction of that times the partial pressure, the partial vapor pressure of that pure solution. I'll just leave it at that. Okay, so remember that this has to be the mole fraction. If this is the mole fraction for the solute, you get the pressure for that solute. If this is for the solvent, then this is also for the solvent. Okay, so with that out of the way, at the temperature conditions of a particular experiment, the vapor pressure of pure water is 275 torrs. Okay, so we know what standard P is. Standard P is equal to 275 torr. Okay? What is the vapor pressure at this temperature above a solution of water containing 23.3% by weight of this compound, non-volatile? That just means it doesn't dissolve into things, you know what I mean. It doesn't dissolve into ions, well, and it's really it basically follows standard rules. It doesn't have the Haas factor in here. Ethylene glycol has a weight of 62 grams per mole. Assume Raoult's law is obeyed, i.e. the solution is ideal. Okay, so we know the mass percentage of this, but we need to figure out what the vapor pressure of water is with this in it. Well, we know what the mass percentage is. So let's just assume we have 100 grams, right? Mole fraction is moles of what we're looking for. Just going to write over here. Equals moles of what we're looking for. In this case, we're looking for moles of the solvent. I think that's spelled right. And then we need the total moles. Okay, so we know that. Now we need to figure out, well, we need to figure out this, but first, let's set up our weight fraction. So we know that for H2O, we have a total of 100. 23.3 is this. So 100 minus 23.3 is equal to that. So we have 76.7 grams of that. And then for the glycol, we have 23.3 grams. Now we just convert these to moles and then plug it into this expression. Okay? So 76 divided by 18. Let me just make sure I did it right. Alright, so 4.26 moles. Okay, now we know what the atomic weight of this, it gives us to it here, 62 grams. So 23.3 divided by 62. That's how many moles there are. 0.376. 0.376 moles. We're almost there. Alright, now what we need to do is plug it into this. Now which one's our solvent? Well, water obviously, right? So water's our solvent. So we plug that in. 4.26 divided by the total here. So plus 4.26. Yeah, I just want to be exact. Alright, so 4.64. 4.64. It would help if you write down the units, not for mole fraction necessarily, but you'll see why in other questions, I believe. Like when you're multiplying this out. Well, not this, but other. Well, basically when you're doing conversions, I should say, like converting molarity to molarity and stuff like that. And then, total. Okay, and that equals, alright. So, 4.26 divided by 4.64. So 0.918. If you realize here, the answer needs to be in 3 sig figs this entire time. We haven't done any adding, subtracting except for here, but really that's just exact numbers, so we keep one past the decimal. But other than that, we're just multiplying, dividing, and these two are the only estimable numbers we have. So answers in 3 sig figs. That's why it's always been a 3 so far. Okay. So now what we need to do is now take this number and multiply it by this number to get our answer. So 0.918 times 275, because mole fractions are unitless, so that's why this unit is the same as this unit, or this unit is the same as this unit, I should say. And that would equal 253. So 253 torr. Alright. Okay.